Okay, today our topic is the properties of determinants. The first property, a determinant is unchanged in value if all the rows of the determinant are changed into the columns or vice versa. So this is how the original determinant, if we change all the rows into columns, okay, so our value of original determinant will be same, will be unchanged, right? So here we have an example. So this is our third order determinant. By the property 1 we can write this determinant also this form. Okay, so here we interchange the all the rows into the column. The first row change into the first column, second row change into second column, and third row change into third column. So the value of determinant will be unchanged for the both determinant here. Okay, so the property 2, the value of a determinant is unaltered numerically but change in sign if the two rows or any two columns are interchanged. So here we have an example. We take here a third order determinant just by interchanging the column 1 and the column 2. Here we have a negative sign value, and again we can interchange the row 1 and the row 2. Again we have a appear a minus sign again, then minus minus will be positive here, right? And property 3, a determinant has a zero value if the elements of one row or any of one column are equal or proportional to the corresponding elements of a second row or second column, right? So in this matrix we can see that first row and the third row are identical, so the value will be 0 here. And here we can see for this determinant the 2 is the common factor of the second column. So just take 2 common here, and the first column and the second column are identical again here, so the value will be 0 as per property of 3. And property 4, if all the elements of any one row or any one column are multiplied or divided by any non-zero factor, then the value of the determinant is also multiplied or divided by that non-zero factors actually. So here we multiply k, a non-zero factor, with first row, then we take the common terms from our first row, that is the k, a non-zero factor, is also multiplied here with the original the value of our determinant. So k is multiplied with the value of our determinant, right? So it also we can also be numerically shown here. So by considering a third order determinant, so this is our third order determinant, since all the elements in the first row and the first row have a common factor. So common factor is actually 2, so just take the 2 common here, and 2 is multiplied with our the value of determinant. Okay, and property 5, so if all the elements of any row or any column of a determinant can be expressed as a sum of or difference between two numbers, then the determinant can also be expressed as a sum or difference between two determinants, right? So numerically we can see here. So this determinant 2 is add with first element of first row, and 5 is add with second element of first row, and 4 is add with third element of first row. And we denote say that our this determinant is actually if we say delta, then this determinant we can also express the sum of uh, two different determinant, right? So here we denote this determinant delta 1 and this determinant delta 2. Okay, now the we find out the value of delta 1. Here the value of delta 1 is 365 and the delta 2 value is 352, and adding both together, delta 1 delta 2, we have 350, right? And we again find out the value of our original determinant, that was the delta we denoted. So delta will be the value the value of the delta will be 350, right? So we can write delta equal to delta 1 plus delta 2 here. Hence the proportion is proved for this determinant. Okay. And property 6. The value of a determinant remains unchanged by adding or subtracting k times the elements of any row or column to or from the corresponding element of any other row or column where k is any given number, right? So this determinant we can also express like this. Okay, and here the k is the common factor or common term of the first column. We take the k common. Okay, as per the property number 4, right? We take k common here, and which is equals to our this determinant, right? Why? Because here the first column and second column are identical, so the value will be here 0 and just remaining this term. Okay, so since the values of the second determinant is 0 as its first and second column are identical, so just remaining terms remaining determinant is this. And it also can be so the numerically here this, if we say this is a delta, right? So we can write this determinant also the sum of the two determinant, right? And we can see that 2 is a common factor for the second determinant, so here take the 2 common, and here our have no any common term, so we can write is delta 1 and delta 2, delta 1 for this determinant, delta 2 for this determinant. Okay, and the value of the delta 1 will be minus 55 and value of the delta 2 will be minus 55, and again we find out the value of the delta which is also minus 55, so we can say that delta equal to delta 1 equal to delta 2.